For this video, we're going to talk about what are functional groups, and we're going to look at one of the functional groups called alkyl halides. So what I've assumed for this video is that you can do all the basic nomenclature, all the regular alkanes, alkenes, and alkynes, and now we're going to add additional pieces. Think of them as branches, but they're very specific branches, and those are called functional groups. So the first functional group that we're going to look at is alkyl halides, and we've actually done these before with the addition of branches using the halogens. Here are some examples of molecules that use function or have functional groups. You can see that the molecules that are real in nature are actually kind of complex. These are both medications. One's for blood pressure, one's for another health issue. So you can see that there's other atoms involved. There are things like there's this O double bond here. You have a nitrogen embedded in a chain. We have a sulfur over here. You have these ring structures. You can see that there's an OH. Actually, this O double bond OH is a different kind of structure. So what we're going to be looking at over the next couple of lessons is all of these different functional groups. You're going to need to be able to recognize them and know what they are, and then apply the correct naming structure for that. So here's three examples. Alkyl halides are probably the easiest. We've already basically done them. They are branches that are added on that are halogens. So iodine, fluorine, bromine, and chlorine. And all you do when you add them on is you're going to add like bromo for bromine, or fluoro or chloro or iodo. You're also going to name the branch that they're on. So you do still number the chain. So this one has the longest continuous chain of 5, and it's on position 2 and position 3. So you have learned how to name these already, and now you're just finding out that these bromine or these halogen groups are actually functional groups also. You name them as you have, and if you look at this upper example up here, 2, 3, 4 trichloropentane, because it's a 5-carbon chain. Remember numbering with the lowest, the branches at the lowest position. This one on the bottom, we have 1 carbon, 2, 3, 4, 5. Looks like a 5-carbon chain. So this would be a pentane also. Actually, it's a pentene because at carbon position number 2, you have that double bond. You have a methyl group on the 2, and you have a bromo group on the 5. So 5 bromo, 2 methyl, 2 pentene. Okay, so you know how to do this. It shouldn't be a big deal.